कर लेते हैं वाला काम याद करना.
Okay, we're going to understand the basic, object definitions behind a simple application. We all know the GUI and applet and views, but we do not know. We all have little understanding of table and column also. But behind the scenes, Siebel has a complete architecture wherein there is another layer called as business logic. So we know that there are three layers in a software, right? What are the three layers in a software? The GUI layer, the lowermost database layer, and the business logic layer. So we're going to understand what does business logic layer really mean in Siebel. Yeah, Siebel application consists of a reusable execution engine. Did we do the SRF and CFG?
Yeah.
Did you see that CFG had the SRF name and the sections and the database name and all that stuff? Did we open CFG and show you? Okay. This is what a Siebel application consists of. A reusable execution engine. Reusable, just forget, I don't know what it means and I don't care. Execution engine means, when you click on the icon, you will see that there's a, when you click on the icon, this is called call center. You click on this and you get this screen, this login screen, right? Let's see that one. Okay, this one we get. If you right click on this and click on properties, you will see it has, I'm going to copy all this. I'm going to go to the end. I'm at the end. Then I go back, I select everything, Control C, and I put it in the notepad. I just copied that and I'm putting that in the notepad. Okay, so now we can look at what was there in that icon. When you're starting the icon, nothing special gets done except this thing. This thing gets executed. This is true for every icon. For example, Outlook Express icon, this icon. We right click on the property and we see this thing. It does not do anything special. It just executes this msimn.exe. You can get the same result by going to this program file Outlook Express msimn.exe and you can start the application. Let's do that. See, I am there, C: program files Outlook Express, and I'm going to start this thing. Once I start this thing, nothing special gets done. Same Outlook Express gets opened. Okay, so that icon is nothing but a path to this exe file. It's a Windows way of saying, let's start this. It's just a visual way of saying the same thing. If you go and click the icon, if you go and click this msimn.exe, same effect will take place.
So
yes, exactly. You can see you can right click at any place, wherever it is, whether it's in the form of an icon or the form of a file, you can just right click and see the properties, right?
Yeah.
It is also starting this simple exe file. So icons or all these things are nothing but just a way to get to these exe files. Okay, so always remember, whenever you are starting an application, you are basically starting an exe file. Okay, so when Siebel gets started, this is the exe file which gets started. Okay, here I will just mention one very important point. We are working on Siebel client which is locally installed. There are three types of Siebel clients. There are five actually: wireless client and PDA client. We don't talk about them. Handheld and wireless client, we don't talk about them. There are three main clients. We discussed that already. Siebel remote, right? Siebel dedicated web, and the web client. Web client has a URL. It does not require a local installation. So this discussion is pretty much not applicable there. It is only applicable in case wherever a local installation is required. For example, in the case of dedicated web and in the case of remote. Okay. So when you click, so for both these clients, you'll be having an icon. When you install an application, an icon gets created, right? The same way for Yahoo Messenger, same way for MSI or Outlook Express, you basically create an icon. You create an icon, and that icon is pointing to the exe file. By the way, for Microsoft Word also, you basically are starting an icon. You know that, right? Yeah. So when you click on an icon, you are starting an exe file. You know that, right?
Yeah.
And what is the name of the exe file? winword.exe. Did you know this? WinWord.
For what?
Yeah, I'll show you very interesting also. You can start Microsoft Word like this also. If you click on start and click on this run, you can start WinWord like this. The Microsoft Word can start. What is happening? You are simply saying, I don't want to go through. I can just type the WinWord to start it, because that is the exe that icon is anyway pointing to. So icon is also doing the same thing. This thing is also doing the same thing. Both are basically starting that same thing. We can start the notepad also like this. You click on run, click on, and they just write notepad. But you need to remember the name of the exe, right?
Yeah.
So that is the main thing. Notepad has started, right? See what was in that icon in Siebel icon. Siebel icon has two main parts: Siebel.exe, uagent.cfg. Okay. Did you do that? Did you do this portion? CFG file. Okay. When you click on the exe file, when you click on the icon, you are in effect saying start this Siebel.exe file, and you're saying that pick the parameters to start. Yahoo Messenger needs certain parameters to start. What are those parameters?
ID and password.
Password. User ID and password, right? We need certain certain parameters to start up. There's another thing that it needs, but the default one is correct one. That's why it never gets used. See, this is the other one. Yahoo Messenger also needs what is the connection type. And if you want to, if there is a particular type, like if you're a proxy server, then you need to put all this here. Otherwise, Yahoo will not be able to connect. So if I try to connect now, nothing will happen. See, although everything is correct, but nothing will connect. Why? Because they changed the connection preferences. The default one was correct actually. That is what my point is. Now it will connect. So frequently more than one parameter is required, okay, and we may not be aware of that. So in case of Siebel, it requires like maybe if not more, at least 150 200 parameters to start. The only thing is default ones are okay, and all those parameters values are written in uagent.cfg file. Is it right? You remember that file? Let's go to this path and see what it is referring. First let's go to the engine path. Okay, the engine is C:SCA752 client bin Siebel.exe. Let's do like this. This is the path you are going to C:SCA752 \client. So I'm going to C:, okay, SCA752, okay, client, okay, bin has this file Siebel.exe. This is the engine. This is what gets started when you click on this icon. Okay. So let's do the next thing. Let's see this thing. Do you know, Hafiz, what this thing is? See, in the days of the DOS, we used to write, commands like copy/f. Then we used to write options. Do you remember that? Okay, that's fine. No big deal. It is just C stands for CFG file. We are just saying the next thing that is coming is the CFG file. So that way you can write it in any order. There are actually 2-3 things that you can write. Sometimes you can write certain other parameters also /p or something. There are some other parameters. So if those parameters, so engine would know, after /c whatever comes is the CFG file. That is how it will know. Okay. So that is only, but basically C stands for CFG. We are trying to tell the engine that this is the next thing that I'm writing is the CFG file. So now please pick that one. So this is the CFG file. Okay, let's see where it is going. C:SCA752 client bin enu. Okay, this is the CFG file. This is the CFG file. You remember that? Remember? This CFG file has all the parameters that Siebel needs to start. As we learned, in case of Yahoo Messenger, 3 parameters are required for it to start properly. And then if it is of some proxy type, then it needs 4 or 5 parameters like what is the name of the proxy and so many other things about proxy server, right? Similarly, Siebel also. Siebel needs all these parameters to start. One of the main things is the Siebel.srf file. The name of the repository file. Siebel needs to know what is the name of the repository file. This is the name of the repository file. Okay. So you will also need to know which applications to start. You remember in your exercises while you used to create an application, this is how this icon is basically pointing to that application only. Okay. Other things are, main thing is it is saying what is the location of the local database. You remember Hafiz, in one of the remote clients, in one of the client types remote, there is a local database. You remember that?
Yeah.
We are saying here where it is lying. I could put it on the desktop also, but I have to give the correct path here.
Where it stays.
It is saying that local section, this is the connect string. Connect string is basically trying to say where the database is. This is kind of CFG way of saying the same thing. Okay. Connect string is equal to this thing. So DBF means this is a database file. DBF, database file. Okay. And similarly for sample, remember we connect to sample also. It is saying this is a connect string for sample. SCS 752 client sample UTF-8 SSC underscore SAMP. Did you know this thing? Okay, no problem. So client sample UTF-8. This is the one being referred here, and this is the exact thing which gets started when you click on Siebel and then you say, okay, I want to connect to sample. Okay. So you can connect to Siebel in 3 ways, right? When you click on this thing, you can connect to Siebel in 3 ways. I'll show you what I mean. Local, sample, and server. You can connect to local, you can connect to sample, you can connect to server, right? You're in effect they're saying like these things Siebel picked from CFG file. The CFG file that is mentioned in the icon. From there Siebel engine knows that this is the CFG file and these are the types of connections available. These connections are written right here. Right here these connections are written. Siebel from here picks the connection names and then comes, and when you say I want to connect to local with this user ID password, Siebel goes and connects you to this database. Similarly, if you say I want to connect to sample, Siebel goes and connects you to this database. Okay, with your user ID password. Okay, so this is how this CFG file works. These are the two main things I can think of which are written in this thing. There are other small things also. It really controls a lot of things. For example, it is controlling, what is an application, and it is controlling what is the fonts and all those things. It is containing what is a local ODBC data source, right? So many things that it's controlling. Rest of the things are not as much important. Most important thing that you will be utilizing as BA is connect string and SRF. You should be knowing which SRF your CFG is pointing to and what connect string it is connecting to. Okay, so now you have a very good feel of configuration file. Configuration file is a set of all the parameters that Siebel contains, all the set of parameters that Siebel needs in order to start itself. Okay, that is the whole idea behind configuration file. Okay, other thing is repository file containing object definitions. Do you know what is a repository file? SRF file, okay, no? So whenever you are making a change, it gets logged in the SRF file. Siebel, all the configurations, all the changes that you do, they are basically in the SRF file, right? Hafiz? Is it right? Okay. So SRF file is basically a repository of all the configurations or all the changes. CFG file, configuration file is not the one which contains configurations, okay? Just the name is very awkward here. Okay, I had many students who get confused between configuration file contains configurations. No. Configuration file contains all the parameters that that are needed to start Siebel. Whereas repository file that contains all the configuration or all the object definitions which are changed by the developers. It also contains all the unchanged object definitions as well. I'm sorry about that. Not only changes Hafiz, it contains all the original object definitions as well. Yeah, I'm sorry, I always call it changes, right?
Yeah.
It really contains all the things, even the original object definitions also. It contains the latest object definitions for everything basically. Okay. A set of physical user interface files that specify how to render the UI in the user's browser. Not a very important thing from the standpoint, just forget it for the timing. A relational database that stores user data. We know that Siebel has a schema which has tables and columns. That is what it is talking about. Okay? Okay, Hafiz? Physical. Yeah. See, physical UI files, I'll just briefly touch. How does it matter to a business analyst? Let's talk about that. See, remember when we start Siebel, this is your Siebel GUI, right? Let's say company wants to put their own icon here, right? Just tell me one thing, Hafiz, do you think this icon will change from every screen? Do you think it's changing? What do you think? Do you think icon is changing?
No.
Do you think file, edit, view, help is changing?
No.
No, right? So what it means is there are certain changing components. Every time you click on something, there are certain components which are stagnant. Is it right?
No.
Right? So let's talk about that a little bit more. This icon, these file menu options, are these changing every time?
No.
No, they are also not changing. These buttons, are they changing? The names of these.
Whatever you click, that's changing.
Yeah, but does the sitemap always is this always here?
Yeah.
So that means toolbar is not changing, but this portion changes.
Yeah.
Right? Similarly, this portion changes, but this label does not change.
Yeah.
Right? And these two don't change. This does not change. Right?
Yeah.
And by the way, these screens also do not change.
Yeah.
Right?
Yeah.
Right? So there are two components to this physical user interface layer. This data changes, this form changes, this applet changes, this applet changes. These views change too, but these screens and these menu bars, this icon and this toolbar does not change. Is it right?
Yeah.
Right. So what Siebel does is, do you know why Siebel takes a lot of time to start? Because it is loading the code for all these things. That is the actual physical layer. So the way I would say it is, this is the way Siebel looks like. This much portion can be put once for all when Siebel gets started, right?
Yeah.
Pretty much this much, right? Right? This much portion can be put pretty much once for all. Means Siebel does not do it again and again. Is it right? Rest, this information it can keep changing. Is it right? UI layer basically means this thing. Data is pretty much changing, but this template, this container page in which the whole applet will come does not change, right? So whatever changes you want here, you cannot change it in the application. You need to change that template. What it means, unless until you are a developer, you don't need to know. But there are two parts to this thing to render this UI. There is this template file, and then there is an ever-changing thing, which is applets and all that, right?
Yeah.
So applets are changing, views are changing, but not these things, and view names are changing, right? But not these top things. So these top things are a part of a thing called as template files. So if you want to change the banner, for example, you have to go and change the template file. You don't change the views because it is not on the view.
No.
View is inside the application, and this is a part of the kind of a higher level thing, which is same for the application. So the template files are for the application. Making sense to you now?
Yeah.
Okay. So, okay. More than this, you don't need like cascade files and what are these things. But basically, these are all for if you want to change anything at this level, like here, then you need to work on this. You will not be changing that. The only thing that you might need is this thing. Not to change, just to understand what they might be talking about. Okay. You might be talking about, can we have another icon? Can we have a different color here? Yes. You need to change the template file. Here. If you want to have a different color, you need to change the template file. Okay. So that's what I can say. Rest everything is like pretty much nothing in this slide here for you. Okay. Yeah, can be modified as required by customers to satisfy corporate look and feel requirements. For example, they might say we want our logo here. They might say I don't want this blue color here. I don't want this blue color here. Okay. They might say can we just shift this sitemap to this thing. Usually they will not say this kind of thing. They will definitely talk about logo. Okay. So they might talk about some other things, but whatever they ask you to change in though according over here in this layer, you'll have to change in those files. Okay. You should know what it means, what they are talking. Okay.
No.
Repository file. We all know what is a repository file, which contains object definitions that specify presentation of data, business logic, data storage. Basically, it's trying to say it contains the applet definitions, it contains the business component and business objects definition, which is the business logic layer of Siebel, it contains the tables and columns definition. That's what it is trying to say. Is it right?
Yeah.
So he's given the example also. He's saying this is a Siebel GUI, this is the applet, this definition is contained there, this is the business component, which is the business object definition, then this is the data. Data basically means tables and columns. In this case, it will mean account, opportunity, product, and contact table. Is it right? Data object definitions. Specify the logical structure of the data storage. Provide a vendor independent representation of the underlying physical relation database. Two principal data object definitions, tables and columns. Do you know of anything else in the RDBMS? Tables and columns. Is there anything else beside that? No, at a table level. There are indexes and user keys and things like that.
Yeah.
Right? But anyway, main two data objects or the objects at the database level. There are three layers, right?
Yeah.
Right? There are three layers, right? These are the three layers.
Right.
The objects at the data storage level or at the database level
Yeah.
are tables and columns.
Okay.
Index, user key, all this primary key. These are all basically at the data. These are all the objects at the database level.
Yeah.
Right, Hafiz?
Yeah.
Specify the logical structure of the data storage. The way that all tables and columns, this is all logical structure, right? He's saying that this is the way the tables should look like. This is the way the account table is this. This is the contact table. This is a logical structure. This is just referring to the data schema basically. Okay. Provide a vendor independent representation of the underlying physical relational database. Provide a vendor independent representation of the underlying physical relation database. A physical relation database is Oracle. He's saying that you give him a physical relation database like Oracle or SQL Server, it will create the same structure on top of it as its foundation. Same tables and same columns. I mean, this line is not very important for you. Specify the logical structure of the data storage, and this line is more important to you. Making sense, Hafiz? This is not very important. You don't need to worry about what he's trying to say here. You should know.
Siebel gives the tables and column.
It is little bit technical here. You may not need as much, but you should know because these are all important system things. You never know, what might come in front of you. So that's why I'm going over this little technical things. And these are anyway required. Everybody did that actually. Okay. So what happens is like when the server is basically retrieving data and creating data for us.
Yeah.
In general, user is doing, but for user, basically user is passing on a request to client, and client is passing on a request to server, Siebel server. Siebel server is not really creating the data in the table and column. He gives a request to Oracle database server.
Yeah.
Oracle database server goes and enters the data. Similarly, tables and columns. When we say Siebel is creating its own table and all, right, it is basically passing on the request to Oracle database server to create the table.
Okay.
So this passing the request to itself and all that stuff, and then managing the table and column, So you just say table and column, store this thing. But Oracle is storing it in the physical hard disk, right? How are those tables and columns managed in the physical hard disk? Is your point? That is what Oracle is managing.
Oh.
For I put it in the account data, my work is over. For Siebel server, work is over. It passes on the request to enter this data in the table, the work is over for Siebel server. But Oracle job is to put it in the actual hard disk.
Yeah.
Right?
Yeah.
So when you ask for, can I get all the rows of the table, it goes to the various pieces of the hard disk, gets all this, then collects all this,
Yeah.
gives it to you. You think there is a physical table lying there, but actually there is nothing like that. Physically, the table is the bits and pieces of information lying at various places. Is it right?
Yeah.
Is it right? This is 1010. So who reads all this? Oracle reads all this. Actually, Oracle and Windows together read all this. So Oracle is basically your actual file management system, actual table management system. It is managing the table. When you are asking, for you see the table like a table which is having a column and this thing structure. You always think of a table like that. But behind the scenes, this is not like that. In the hard disk, it's 101010. So Oracle is managing all that. He's giving you a very logical way of looking at your data. Okay, tables and columns and all that. So if you specify something, Oracle remembers that. When it is representing data, it puts it back in front of you in the same way. When you're
Like
storing,
we keyboard, we push A, it goes in 0101 and it put the image
exactly,
A.
exactly.
Okay.
So all the interactions are like that. There are many multiple levels of interaction. So Oracle is maintaining Oracle product. That Oracle product, what is it doing that? If SQL is making tables and columns, that is basically making that happen. The tables and columns, just tell him this is a table and column, then it stores like that. SQL does not really need to worry about 1010. Oracle and Windows are together basically making that happen. Okay. So it is giving them the idea of table. It's feeling that you're seeing, okay, this is the table definition and this is the table I created.
So Oracle is putting in machine language.
Exactly.
Okay.
Right. So all this deep work is, but you will not never need all this. You just want to make sure you can connect to things. So provide a vendor inventory present the underlying physical relational database. Just useless. Two principal data object definitions, tables and columns. Right? When you are creating your data objects, you will not think in terms of hard disk and all those things. You will just create tables and columns, and Oracle will store it. Okay. Business object definition. There are business object definitions specify the business logic for the application. Did we discuss what is the business logic? Right? Two principal business object definitions: business component, business object. Okay, we know that. What is the screen? When we go to about view of any screen or any view, like we're in this view, assets, all assets view, right? If you go to help, about view, yes, you can see the screen name, you can see the view name, but most importantly, with reference to our discussion, you can see the business component. This you can see the applet name, internal unique name of the applets. There are two applets, right? This is the lower applet, this is the upper applet. You can see the name of the business object, you can see the name of the business component. Is it right? So this is exactly what he's showing here. He's saying that this is the business object, this is the business component. Business object is very important, but most probably a BA will never be working on it. Only some hi-fi configurators have to ever use that, but even usual configurator also does not use that very much.
What is business object?
Yeah, that's what it's less important. So let's talk about business component more. Business object is less important, especially for the very less time that we have.
Okay.
Most important thing is business component. Okay. Business component carries that business logic definition. Okay. So business component is nothing but applet is nothing but a presentation of data. Remember we talked about that data is lying in account and contact, right?
No.
But in the contact, in the applet, in the contact applet, you see the account name. Is it right?
No.
The applet is only presenting that. Where did you combine this data and created it back into content and account? In the business logic layer. So the way business sees the data is what you create in the business logic. Let me try to say what I really mean. For example, you're in the context screen, right? Okay. Do you see the name of the account here? Is this the way it is stored in the database? Priya. I just exported that. Right? Last name, first name. I mean, what is the difference between Excel and that? You know, here also you have an Excel form of way of representing. It's just a little bit more sophisticated, but here also you have the Excel. Is it right, Priya? Right? But, right? So, is it right? What I'm trying to say is last name and first name are stored in the contact table, but account is not. Do you remember that? Account is stored in which table? Account table, right? Here we have only the connection between contact and account. Do you remember that? Is it right? Now, very importantly, so contact and account have been connected here, right? By the foreign key and all those things, by joining and all those things, right, Hafiz?
Yeah.
Right? What is the business logic layer? Business logic layer is where it takes place. Let me try to explain what I'm trying to say. In the database, contact and account are stored like this. Is it right? Account row ID and count name. Last name, first name, and account foreign key, which is basically nothing but it is referring to this row ID. Is it right, Hafiz?
Yeah.
This foreign key is nothing but this is referring to this row ID. Is it right?
Yeah.
this account foreign key is nothing but it is referring to this row ID. Is it right, Hafiz? Yeah. So so these are stored separately. We understand that now. Okay. So this in this we know that the data is only represented. Whatever data it gets, it just puts it. That's it. If it gets separate to content and account, it will not try to combine it. It will just put it there. Right? Right? So let's say your user comes and says, I want to see all the contacts and their corresponding account. That's why they are buying Siebel, otherwise they could have used Excel, right? So Siebel, when they get the command, Siebel engine gets a command, you enter the data, Siebel separates it, right? Puts it in the contact table and account table. So that the storage space required is less, right? That is what the whole purpose of RDBMS is, right? Relational database management system. That's what it means. It basically maintains the relations. It does not try to repeat the same information at the same place again and again, because there are, let's say, 5 contacts associated with one account, right? And if you were not to put the account foreign key, if you had to put the whole of the account name and everything, then account name would have repeated 5 times. Is it right?
No.
Let's say this is the data that you wanted to store. Just think this whole name would be repeated again and again. And so with all the other information about this account. The whole idea of RDBMS is you store the account information separate, you store the content information separate, and you just store the indicator or the reference to that account, pointer to that account, right? Right? So you will store it in the separate tables. This in the separate table, this information in a separate table, right? And here you will put only the foreign key. For example, like this. So this is the account table, and here for the account, instead of the account name, we were storing ABC whole pharmaceutical here, but now we will just store the XYZ. Is it right? That is the whole idea of RDBMS, right? Right. So this is how Siebel will store the data, or the database will be having the data in it. You know, where does the data get combined? The data gets combined here in the business logic layer. Here is what you tell Siebel. Here is where you will tell Siebel how to combine the data. When the user enters the content and the account information just like that, he does not care where it is going. But what Siebel is doing is Siebel is separating it, putting the content data in contact, putting the account data in account, putting the reference for the pointer or the foreign key to the account in the contact table. Is it right?
No.
Or putting the appropriate foreign keys. We know that. What if it is a many-to-many relationship? It will put it in the intersection table. If it is a one-to-one relationship, we put in the context, so on and so forth. Let's not get confused about that. But we know that what I really mean is, whatever the relationship is, according to that relationship, it will populate the tables.
No.
Right? This definition is written here in the business logic layer. Okay. This is just the presentation layer, where the data comes out and shows. But this is not the one where the data is combined or stored. It's here only the data is shown. All the code for showing the data is written here. Like code for this middle name, Mr. and Mr. Miss, all this is part of the business logic. This is where the data gets combined. But sorry, also I'm sorry, all this data is in the business logic, but these labels,
Oh, there in that.
yeah,
Yeah.
no, they are a part of the presentation there.
Yeah, because they're not showing.
Yeah, yeah. The length of the fields, so and so forth. All this, how the zip code, whether zip code will be here or zip code will be right below here. City is at this place, not at this place. All these are part of the presentation. How the data is shuffled around. Making sense to you?
Yeah.
But what data is coming, it's all governed by business logic. Okay. Similarly, what is the zip? Whether the spellings of zip code are ZEIP space code or ZIP without space code, right? Or this column should be written or not. These are all part of the presentation. You can write anything in the applet. It will start showing here. It is your smartness. In case of at the place of zip code, you are not putting anything else. You are connecting the right table column here. You are connecting the right business component field here. Making sense? If you connect zip code with address line 1 in the table column, what will show here? address line 1 only, right? Any,
How will you give the connectivity?
we'll do that.
Okay.
Okay, yes, that's a very good idea. How to specify these definitions? What is connected to what,
Yeah.
right?
Yeah.
We'll do that. Okay, so keep that question in mind. We call it mapping.
Mapping. Okay.
How is zip code mapped to that zip code? How does it do that? I'll show you how to do that. You will never be doing that mapping. Okay, but you should know. Okay, business logic layer is, if you ask me, is pretty much the most important thing now, because this is how the business. Why do they call it business logic layer? There's not big reason, but basically this is how business sees their data. If you ask me, last name, first name, account, this is my data.
No.
I will say, Mr. ABC, this thing, ABC Pharmaceutical, I will never think of these two as separate entities. I might, but I may not. Is it right?
No.
So business sees the data in a whole thing. This is the order. What is the name of the account for that order? This one. And no order can be completed without the name of the customer, right?
No.
Right? So what is the name of the customer? For which customer this order is? This is the customer. What is the order? What is the customer for this order?
No.
Right?
No.
Any order Excel, if you have the order information, it must have a contact information. What is the number for this guy? But we know Siebel calls it two separate entities. One is contact data, one is order data.
No.
And how it is stored in the database? In two separate tables. But the way customer sees it, so the way business guys see it is
No. No.
connected data, one data. They don't see it as separate data. They think this order, this customer is one thing. That's why we call it business logic. That here, this is where the way business sees the data gets combined, gets created.
So any combination you want, you can just create in the beginning of
Yes, 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 yes. Out of the box combinations are there. Pretty much other combinations can be created too,
Oh.
right? Money is required for all those things. So you will be, for order management, you will be knowing what are the various combinations required allowed.
Okay.
What are the various present out of the box. That is what your skill is.
Yeah.
You are not skilled in making these combinations. You are
Oh.
skilled in knowing these combinations. You look at the data schema. Okay, this is possible because of the fact you know that these combinations are possible.
Oh.
Is it right?
Yeah.
So since you asked this you will become a master of this thing. But this is where it is written what all combinations are possible. I think we went through this thing before.
No.
No, I and John did. Remember one too many. Remember?
Oh, okay.
Remember?
Yeah, that's right. Oh, okay.
Right? I'm just making it a little bigger. See, this is the part movement. This is the order. So these are the various orders. Okay, and order type it has a one-to-many relationship.
Right.
With inventory location, it has a one-to-many relationship. It has a one-to-many relationship with right. It has a one-to-many. It has a many-to-many relationship with internal organization. It has a one-to-many relationship with party. Right.
Yeah.
Right.
Right.
It has a many-to-many relationship with position. So these are the combinations which are already there. I will not call it combination. I'll call it associations. Okay. Yeah, these are the associations which are provided out of the box. So you need to know how these associations are working before you go. No, you can get by if you know how to think around these things. That's what the whole thing is. You don't need to know all this by heart. You need to know. You should be keeping it in front of you, and you should be able to think in terms of this thing. Oh, you need order to asset functionality. I can provide you that. That's how you think. Okay. If is stored in the business logic layer. This is where the business logic layer comes. Okay. Business logic layer. Is the data stored in business logic layer?
No.
Then what happens there?
It retrieves from the database, and whatever you command it, then it arranges in that order.
Perfect. So this is a series of commands.
Yeah.
It's a series of instructions. It is a way how you should join this data. It is not the actual join data. Otherwise, the whole purpose of RDBMS is defeated. The purpose of RDBMS is to store space, is to save space by storing it separately. If we store it together here, then whole purpose is gone. So it combines the data at the runtime dynamically and presents it in the presentation layer. It gets the data from here, combines it here or associates it here, then presents it here. That's the whole idea. Is it right, Priya? So now we understand how the mechanism works. Siebel servers do all this work, okay? So what is the relation with server and all this? Let's not talk about that. But user enters a data here. He's sitting here somewhere, okay? User is sitting here. He's sitting and working on this presentation here. What he sees of the system is the applets and forms and all those things. That's where he enters data, right? All that work gets done here. Okay, he's entering the data. But once he enters the data, Siebel software, for all practical purposes, the generic name, or the Siebel server basically combines the data and instructs the data, and then it bifurcates the data because it knows the definitions now.
Yeah.
It will ask the RDBMS, can you please store the content information here? Can you please store the account information here? Right? Then user says, I want to see all the accounts. He enters a request here. Basically what he does is, how does he enter a request? Do you know? Let's see. How does it happen? When you're clicking on this contact and you click on this account, now you're submitting a request. I want to see the contacts and accounts. So this is what the presentation layer request you have generated. It goes here in this data. In this presentation layer you have said it goes here. Siebel server receives this request, processes it according to the rules, instructions, commands you have written in the business logic layer. You or the developer has written. Siebel server reads it, stores it, bifurcates the data, puts one in contact, put one in account. If there are 3 or 4 bifurcations, it will do that also, right? Siebel will break it into pieces, store it into, and gives the instruction to the database server, Oracle database. Can you please store this contact data in the contact table? Can you please store this thing in the account table? Can you please store this thing in the product table? So on and so forth. Okay. And in this case, it will say, can you please bring this data from the contact table? Can you please bring this data from the account table? Then it will combine all this in the business logic layer. Then it will put all this thing in the presentation layer. Okay. It happens instantly, right? Isn't it right?
Yeah.
Right? Okay. Okay, so we know the importance of this thing. Okay, so we come back to our original discussion. So what we are discussing is business objects, business components. Yeah, when you are making these things, you are making it in the form of business object and business components. Okay, business component is more important. Business component is pretty much the thing that he sees. Like this content account are separate tables, right? You combine it and you're putting it in the contact here, right? You're putting it in the basically contact area, content management area, right? So you will make a contact business component, put all the accounts details there. Say that this is how you join this table like this. You have to put a joint definition, right? You put a joint definition, right? You put the joint definitions in that business logic layer and say, and that is basically instruction to Mr. Siebel. You go there, pick all this data, combine it like this, and show it whenever I ask you to put it in the presentation there. Okay. Business component represents one fundamental business entity in the enterprise. Yes. For everything, for every business entity that you will perceive. Remember, in case of Toshi's project, what all entities do we have? Applicant, application, interview, activity. Now, interview and activity are stored in the same table. S_EVTs_act. I will for purpose of easiness, I'll call it activity table. Okay. And I will call S_org_ext as account table. Okay. Okay, just for ease. Okay, so interview and application, they are both interview and application, they are both in the activity table, but because of but they are separate entities, right? So what we do is, this is another thing of the table I forgot to tell you. Sometimes we use the same table to put different entities. For example, contact and employees. Previously Siebel was using the same table for this thing. So separate tables for this thing, contact employee. Soon they realized last name is same, first name is, everything is going to be same. Only one thing is different in case of employee. Contact also has an address, employee also has an address. Employee is related to the contact, to the company. Contact is related to the account, right? But there's only difference, right? So they said, okay, let's merge them. Let's use the same table. But these are two separate entities, as we know. Business wise, these are two separate entities, right? So that would mean Siebel will store it same way in the same table. It will bring it out and create two definitions. Okay. Obviously, at the database level, you have to do certain design. For example, in this case, the design required will be, you will maintain a check mark. Every person who is an employee, you will maintain a check mark. Right? When you say, please you user goes in the presentation layer. User goes here in the presentation layer, and he says, I need the list of all the employees. This is what I'm doing. I'm saying I want the list of all the employees. I will be by default be taken to my employees or something. Let's see, where do I go? Okay, I'm in the all employees. So what is it doing is, it is this employee, this area is nothing but presentation layer. So it is nothing. The request is actually being received by which layer? Business logic layer. The business logic layer says, okay, these are the employees. There I have put a definition. All the ones in the contact table with the check mark. In the business logic layer, I put this definition. Right here, I put this definition. Okay, so Siebel goes here and learns what definition I put. The developer has put basically, or the business analyst has put. And then it goes in the contact table. Out of 1 million records, it will bring only those 800 which have this check mark. Bring it back in the business logic layer. Bring other data also if there's something is required. Combine all this data, put it in the presentation layer. This is how it works. So we learned two things. One is it combines data from different tables. It also subsets and sets, and brings a subset of the data within one table also. We all know that it basically filters on the basis of certain criteria. I want the accounts of this type only. But sometimes we actually create two separate types of data. Separate types of data at all. Two separate entities altogether in the same table also. For example, employee and contact, they are in the same table. They are two separate entities, right? In case of Toshi, interview and application both are in the same table. So this was a long discussion we had.
Activity में पे डाला था ना.
Yes, exactly.
No foreign key in that one.
No, foreign key, let's say for activity, as activity it should have a foreign key to account. So there are foreign keys for that. Let's say as an interview it should have a foreign key to applicant. So there is a foreign key for that also.
But when you merge those two tables together.
We are not merging those tables together. We are using same table. I will call like this. This is the same table. I'm storing it in the same Excel. I'm putting in the same Excel.
No, but when you say contact and what other one?
Employee.
They are in the same table.
Yeah. So this is how it looks. The contact table. There is another field that we are keeping just for employee flag. Okay. Whatever, right? So this is the way the data looks in the physical layer, okay, or in the database layer. But when in the business logic layer, it obviously data is not kept like this, but it will become like this, okay. This is the way data will look like in the business logic layer. As you guys know, in the business logic layer, the data is not present all the time. It is dynamically created, but this is how it will look like in that layer. Is it right, Hafiz? Right. So I'm not saying it is merged. There is nothing like merging. I'm just using the same table to put this data in. Right? That's how I will say this thing.
How it differs from that?
In the foreign key, see account table is different, right? There is a separate table.
Yeah.
So we combine the data from two tables.
Right.
In this, we are having the data in the same table. We just filter it and take a different subset at a particular point of time.
Okay.
So at a time he will not be asking, show me all the contacts and show me all the employees. He will be saying either show me all employees or show me all contacts, right?
So in this table, account is part of the contact table. Is that right?
No,
Or is it still separate table?
account table is a separate table altogether.
Okay.
Account ID is kept here, right? Right, Priya? Account ID is kept here,
Yeah.
right? As always. What I'm trying to say is,
As a reference to connect to that account.
Yeah.
for that business thing called as that only the contacts will be having the accounts, right? Employees will not be having the accounts, right?
Yeah.
So that is showing in the database like this.
Okay.
That's what I'm trying to say. It is showing in the database in the form of this thing. Like this does not have an account information, that business thing, and contact have an account information associated with them as part of the business, right? This association is maintained like this, and it is showing that. when you merge two, not when you merge, when you use the table for two separate things, for every separate entity, you will have to maintain a flag or something. Okay, or if there are one or more entities, instead of you know what is a flag, right? Yes or no?
Yeah.
You know that, right? Did you know this? Flag is nothing but yes or no. We call it flag. You know, you flag it, you check it. So you could write null or this thing. Usually people flag means yes or no. But we could have said type. As there are only two types here, which we can use yes or no. But if had there been multiple types, for example, in case of orders, there are multiple. Remember, there are sales order and all those things written in the same box. He was trying to say that if order table is used to put sales order, service order, they are not separate tables, right? And for every type of order, there can be separate attributes. For example, in this case, content has another attribute that it has an account associated with it. Do employee have this thing? No. Similarly, employee might be having something called a salary. Will the content be having salary associated with him? No. That's what I'm trying to say. So there will be some difference in the table. It's pretty much looks like merged. But we are not merging the tables as such. Nobody's merging the table. Nobody merged the table. Okay? So Siebel is basically using the same table to keep this information. Okay? So at the business logic layer, these are separate entities. And Siebel will create two separate entities. You or a business analyst or a developer will create two separate entities and tell them the definition. Tell the definition to Mr. Siebel engine how to store it in Siebel data and how to retrieve it from the database. Okay? Usually the convention, now the business component is basically taking the data from one or more tables. Is it right?
No.
Right? But what we still say is it references one main table. That's how they are named. Contact business component basically is named because its main thing is contact table, right? Similarly, account business component will be made referencing account table, S or EXT table. Activity will be referencing S underscore EVT underscore ACT table. Okay. Can include data from additional related tables. We know that. They have to be related business wise. He's just trying to make a point. That's it. I don't see any special in that. We all know that they have to be related. Otherwise, why would we combine them data?
Yeah.
Right? So that's what he's saying. Represent a logical grouping of data from one or more tables. Yes. It pretty much represents a logical grouping. Business wise, the logical thing that makes sense. Contact and business account side by side. He might also say the user might also want to see the product also that he has got. For every product, I want to see which account it is. For every order, we want to see what product did they buy, which account it is for, which contact was there. So then you'll have to make order as the main business component, and that business component will be connecting to main order table and to account, contact and product table. Is it right to get all this information? Is it right?
Yeah.
Is it right? And let's see what all connections are shown here in general in the GUI. For employees, so for contacts, see these are all the associations, contact and account, right? So sometimes people can ask for contact and account information together, right? That's why the view is there. Now that means behind the scenes, this business component, contact business component will be having association with account table also. So all these are basically various associations. Okay.
Oh, so what you can see here is the association.
Yes. So that diagram that I showed,
That's based on this one.
this is based on
that.
that. Yeah. Okay. Same thing. Okay. A business component can be thought of as a virtual database table spanning multiple real tables. Yes. Forget database. For me, when I'm putting the data, it is just going in an Excel like that. When I click on this thing, for me the data is stored like this. So you are basically creating a virtual table. Okay, what all do you want in this table, Mr. User? I want this contact name, I want this account name, I want this account type. Okay, I created the whole table. Okay, you'll get all this. Behind the scenes I'm mapping into real tables, but it's a virtual table. This is where my whole business analysis stops. Not business analyst types analysis, just the whole analysis stops. After that it's just a matter of presenting. Is right? So I just combine the data from different tables and the way business would like to see. And I just combine it like that, and then it is ready to go. It is kind of a virtual table. It is filling the gap between what people want and what database stores. If database could store it in the same way as people want, we did not need both of these. We just needed presentation layer and a database layer. Then we would have not required this thing. Just put this thing, get this thing. Put this thing, get this thing. No combination, because that is the way. But unfortunately, RDBMS technology says if you don't do like this, you'll end up wasting a lot of space. How much more?
Too much.
So more
Exponentially high. It will not be like 10 times higher. It will be like 500 times higher space. So if your space is like 1 gig, usually they have like terabytes of data. If they have 1 TB data, they're spending, let's say, $10 million. They will end up spending 500 TB, which means $250 million. Lot of difference, right? Really exponentially high. Okay. Yes. It organizes the data in the way the user chooses to view the data. Right? As I said, right? This is the way. This presentation is just presenting. She says, I want these things in the content. So you put all these things in the business logic layer and make it ready for him. Presentation layer is simple. Reason is very. Let's see what other things the presentation. Let's say you are using a cell phone, right? Business logic layer will be same. The way data will be combined. Only the presentation layer will be different. So if you're using a different physical device which has a different presentation, right? That is a different presentation, right? It will be in a smaller screen. Applet will not be the same. So this is the only thing you need to change. It will be also interacting with the same business component. Making sense? This is, see here, you're building the application becomes complete here pretty much. It becomes complete here. After this, it is just how to present the data. Making sense? Right? You know, like
उसमें भी तो email आती है, बस एक line आती है.
You cut various vegetables and all those, everything is ready. It's in a big bowl. Now whosoever says I want a small, then you make a small pack and give it to him. He said big pack to him. Right? Right? Whereas in the case of Golgappa, he keeps things separately. He combines it at the runtime and then gives it to you. So it is pretty much ready now. Now if somebody wants to see it in tomorrow, there's a new technology comes. People can see softwares on TV. What do we need to change? What does Siebel needs to change? Nothing. Sorry, just the presentation layer. Because of the fact, only the presentation has changed in the world. See your point?
Yeah.
If tomorrow you want to see it in some other small device, some big device or anything, maybe in the mouse here, right here, with some different protocol, what will you change? Just a presentation layer. You don't need to do anything else. You know, it organizes the data in the way the user chooses to view the data, and rather than by how it is organized for effective data storage. In this line, he is clearly saying that effective data storage, RDM is nothing but an effective data storage mechanism, and that is the reason you need to fill this gap by having a business logic layer. You make it, you pick the data and you combine it again, combine it back, and then present it to them in the presentation layer. Business object represents a major functional area of the enterprise. For example, account management is a collection of related business components. Account business object has one business component serves as the master or driving business component. Okay, useless thing. The only thing you should remember is every view here is mapped to a business component, right?
No.
Right? Every view in C, basically just remember, like, you know, this contact, whenever this is the screen is contact, that means the business object will be contact. Okay? Okay. So just remember that. So every view that is here is having business object as contact. Okay, just remember that. Business object is important, but not that important that you spend your time on it. And one business object is basically a combination of many business components. Okay. Business component reuse. A business component can be defined once in terms of a logical collection of columns for one or more tables, then used in many different business object contexts. Yes. Let's say you make one contact with the contact and account and all this information. Then you want to have an order. Okay, in order you want to know what is the order, what is the contact name, what is the account name. There are two ways it can be done. One is order will have an association with account. Other ways, order is having an association with contact,
Contact
has association with account. You see your point?
Yes.
So he's saying you can use the same contact business component. And order and business, this contact business component can be combined and all the data will be available to both of them. Making sense?
Yes.
So in the order screen, you see contact, right? Yeah. So order on the top and contact on the behind the scenes, right? So upper applet and lower applet. You know that all the applets are mapped to only one business component. Did you know this?
Yeah.
Did you know this? All applets are mapped to only one business component.
Right.
One business component can be mapped to many tables. You remember that? Okay. This is the architecture of Siebel, right? This is your user interface layer. Screen, view, applet, control, business object, business component field, table and column, database management system. Forget database management system. We all know that what database management system does now. These are the three main things. Table and column, we all understand what it is. Business component and field. Business component roughly maps to the table, but we know that one business component can map to multiple tables. So this relationship is, there are many tables for one business component. For one applet, there is only one business component. Okay. In one view, there are multiple applets. So that means in one view, there are multiple business components. Making sense?
Yeah.
Yeah, it just doesn't make any sense. I think it's just okay. I mean, if you just cram it, that's enough for now. There's nothing really special in it. Okay. So this is nothing very important. UI object definitions. We all know UI object consists in the UI main things are screens, views and applets. Actually, I would take the liberty to say even controls or these various fields. Various controls. Just to let you know, in the GUI, we have always been calling those various fields in the applet, various fields in the applet. That's a kind of a wrong way to say. The right way to say is controls in the applet. And when we say tables and the fields, that is again wrong. We should say tables and the columns. So table has columns, applets have controls, and when you say field, in Siebel language, to be a purist, business components have fields. When you're talking about business components, with reference to them only, we should say fields. When you're talking about applets, we should talk about controls. Should call them controls. So these are all. What is this industries? This is a control. Main phone number, this is a control. Site name, new. Do you see any column here? No. Do you see any field here? No. None of these is field. All these are controls. In the Siebel language, maps to a particular field, one field, and one field maps to a column. Only here there is a one-to-many relationship. Okay, rest everything is pretty much same. So this is a usual thing in your in your Siebel life. You will be asked, it will be a part of your job to find out, what is the table, what is the column being used, so that you can analyze the data and do some analysis and recommend the solution. So frequently you will come here and you will see the applet and the control and the business component. In the GUI itself, you can see, let's say you are here and you want to find out what is the applet and the control and the GUI. You go here to the help, about view, right? You will see the so it shows that this is the applet and this is the BC, right? So your job will at that time will be to go behind the scenes in tools and see what are the fields, what are the controls, and what are the tables and columns which are there. Okay, it will be written very easily and it is very easy to do, nothing very big. Okay. So I would take the liberty to say that even control is a part of the GUI. Okay. Screen, view, and applet. Okay, these are all. As mentioned earlier, the physical of the user is stored in the template and the files, the physical, their addition of object definition. That's fine. Applet object definition specifies a list or form that occupies a portion of a civil application window. We know that. What is an applet now? Okay. Yeah, just a minute. Hafiz, you know that there is another one type of applet. Do you remember that? There is a list applet. There is a form applet. Huh?
List and form applet.
There is one more applet. Explorer. Remember tree? Tree applet. Remember group administration positions? You know there is hierarchy of tree.
Okay.
Yeah. Remember
Yeah.
the tree applet. Okay. I'll show you that. And it is written very clearly here that it references one business component. Applet object definition continued. Consists of multiple list column or text box controls of object definition. References a field in the applet referenced business component. Specify how the field for the field is, how the data for the field is displayed in the list or form. Nothing very special. It's just saying that it references one field. Every control references a field. Okay. Every control in the applet, it references one particular field in the business component. See this written. Okay. View object definition. Specify a view in the Siebel application. We all know that there are various views in Siebel, right? References one business object. That's fine. Consists of multiple applet object definitions. We know that there could be one or more applets. Each applet must reference a business component in that business object. Yeah, so each applet must be referencing a business component. In that business object, that's important, that's not important. See, I'm not trying to touch the business object here, right? Screen object definition. Specifies a screen in a Siebel application, is associated with the major function area of the enterprise, consists of multiple view object definition that usually references the same business object. Administration screens are an exception. Yes, we know that. That one screen consists of many views, right? And they all basically, we will logically combine the screen. I will not put the employees views in contact screens or account screens, right? So I will logically combine them, right?
Yeah.
So it is in our hands. So in the developer's hand, that if he's making an account activity as an account asset, he should make the parent screen as account, right? Otherwise, the whole flow will get broken. You know, the whole users cannot find their way in that, right? Application object definition specifies a particular collection of screens available in a Siebel application, consists of multiple screen object definitions. Application object definition specifies a particular collection of screens available in a Siebel application. Okay. We know that application is the higher level than screens. I told you, I think before, that application is a combination of multiple screens, right?
Yeah.
That's what he's trying to say. Major object definitions are related to each other like this. One business component has multiple fields. See, this is wrong here. Applet can be having multiple business components. Applet references multiple business component references multiple tables. This is right. Rest everything looks pretty okay. One table has many columns, one business column many fields, one business column has many, right? Okay. Object definitions are grouped into 3 layers with different subject matters and purposes. Referenced, yeah, we call these as UI layer, we call this as business logic layer, we call this as data layer, right? Or database layer, or data objects layer, okay? Are configured to meet business customer requirements by using an HTML editor to modify the templates and other physical UI files. You will not be doing that, never. Siebel tools to modify the object definitions, yes. We will be using Siebel tools to modify the object definitions like applets, views, screens, like business component, business objects, like tables and columns, okay? Okay. This model showed you how to describe the major types of objects, describe the relationships between them. Okay. Yep. That's what we did.